Number 18. Now this is going to be 2.6, right?
Yes.
So MTS, ALG2, HW 2.6, questions 18 through 21. The reason why I started with 18 is it's a little bit better than 19, and I want to show you two different things. One, the way I like to teach students is use your brain. Okay? They say, they tell you a lot of times, oh, use this formula, use this formula, use this, use this, use this. If you, it's an A, B, C, D answer, right, on a test. Who cares what formula you use? Get the answer. Okay? If it's an open-ended question where they want to see you using that formula, then use the formula. Okay? But most of the ACT, the SAT, the SBAC even, very few times do they ask you to show the work with this specific formula. On the SBAC, most of the time it was just like, hey, show your work, right? They tell you to do something, but just show your work. So you get to use whatever formula you want, okay? And I want to point that out with this, because they're telling you, use the quadratic formula. The quadratic formula is negative b plus or minus b squared minus 4ac all over 2a, okay? That's a quadratic formula with respect to a quadratic, whereas the quadratic is ax squared plus bx plus c, and we've talked about that when we're doing the factoring, right? When we were doing that graphing, where we had 2ax plus b, right? Okay, when we're trying to find that axis of symmetry and all that stuff. Okay. Now, if you can't factor. If you can't easily factor, use the quadratic formula, because it works every time. But factoring is the easiest way to do something if it's factorable. And it's really easy to tell because you should be able to go, okay, the product and sum, right? The product is 9. The sum is 10. What two things multiply to be 9? But they add to be 10. 1 and 9. Or 9 and 1, because big number first, right? So 9 and 1. Good. So this is actually factorable. So you could use factoring to solve this. You don't have to use quadratic formula. Okay? Now we use that 5-step method, right? And that 5-step method is 3x and 3x, and we tell ourselves that there's an extra 3, because 3 times 3 is not 3, right? But this is that extra paste we put down so that the glue can be done evenly. It makes the work easier. Okay? Next, bring down your sign. This sign tells me that they are same or different? Same. So they both are negative. Okay? Alright. Two numbers that multiply to be 9 and add to be 10. 9 and 1. Okay? Last step. We got to take out our 3. So you take out your 3, and you're left with, how many times does 3 go into 3? How many times does 3 go into 9? 3. Okay. How many times does 1 go into 3? 3 times. How many times does 1 go into 1? 1 time. Alright, so that's your factors, right? But if you want to solve this for the zeros, like they're asking you, you have to make it equal 0. And then solve. Plus 3 x equals 3. Plus 1, 3x equals 1. Divide by 3, x equals 1/3. So you get x equals 1/3 and 3. Because I always put little to big. Okay? And that's it. You didn't even need to use quadratic formula, right? You just use factoring. Okay? So like I was telling Christiana, she's like, you have to use quadratic formula. Only when you have to. Only when you have to. Because there's 1,000 ways to solve this. If it's in vertex formula, why would I make you multiply everything out so that you could use quadratic formula? Just use the vertex. Right? And it's the same thing. If it's factorable, factor it. Okay? It's like this guy. Now, remember the first step is GCF, right? GCF. So, what goes into these? What goes into both of those? What goes into x squared and 6x? What goes into those both things? Anyone see anything in common?
An x.
An x. Good. So I can pull out an x. Now if I take one of these x's away, how many are left? 1. Good. If I take one of these x's away, how many are left?
1.
None, right? I took it away. Alright, so it's x plus 6 times x. And then you set each one equal to 0. And you solve. Oh, x equals minus 6, right? And x equals 0. So x equals negative 6 and 0. And it's that simple. Okay? Was that bad? That's solving for zeros. Okay? I'm guessing that this next one won't be that easy. I don't know. I never try this stuff out before I teach class. I always want to learn while I'm teaching. Okay? So, sometimes I make mistakes. And it pisses you off. And that's okay. Because I want to show you that everyone makes mistakes. Okay? So, this next one. Let's see. Can we think of two things that multiply to be 9, but they add to be 2? Can we think of... Huh? No, we got to add. Remember, that's the second sign. Tells me what to do. Good question, though. Good question.
That's not a thing.
Now, we can't do that, right? That's not factorable. Okay? So, even though this was factorable, and it was hard. We had that 3 out in front. That's a lot harder than with nothing, right? This one was pretty easy. In this one, we need to use what's called the quadratic formula. All right, let's do it. We have to remember something. A, B, and C. A, B, and C. The sign goes with it. Okay? The sign in front goes with it. That's huge. Okay? Now, when I write this out, I always say it in my head. Negative B. Notice I didn't write the B. I have that on the top of my paper. Negative B. But when I write it, I say it and I write a parentheses. Every time I say a letter, I write parentheses. Negative B plus or minus the square root of B squared minus 4AC all over. All of it. This is where students make mistakes. They don't put it all over it. They'll just put it under this. Okay? All of it. Okay? All over 2A. Okay? And once I have those parentheses there, I can just plug into them. Right? Okay, so B. What is B?
-2.
-2. Good. So not -2x. Good. I heard it. I heard it, right? Because that's what half of my students do. -2x. It's not the x. And that's why if you look up here, I only circled the numbers. Okay? So remember that. If you thought in your head 2x, -2x, remember to do this circle. Also, what people don't do is they don't put the negative. Okay? So you didn't put the negative. Make sure you circle the whole thing. -2. Okay? Not the x though. Alright? Very, very, very important. Next. What is A? Because it says 4A. 4A. What's A?
-1.
-1. Okay. Good. That's a hard one. Because there's a negative out there, but I don't see a 1. Right? And sometimes you don't even see a negative. There's nothing out there. But there's a hidden 1. Okay? So you have to remember that. Even though there's nothing out front, there's still a 1. Okay? And this was 2A, right? So we might as well plug that guy in too. Okay? -1. Does that make sense? Plug your A's into both places. Okay? Alright? And then the last one was C. What's C? +9. Good. Now you can put in a +9 if you want, or you can put in 9. Just remember, they all multiply. Okay? They all multiply. So remember, if you put in a plus, that's fine. Remember their parentheses. If your parentheses aren't there, you're not going to remember to multiply. Okay? Alright, and that's it. This is what X is. This is it, man. Now it's just math. Basic math. Okay? Junior high school, elementary math. Okay? Alright, so what's a negative and a negative? Positive. Okay? Alright. Don't forget to put that square root. Students constantly forget to put that square root. Okay? Every time you got to write that square root. Did you need a book or anything to write on? You need some for notes? You want me to just get you some paper?
Did you take my homework assignment? I gave one to Grace. A little bit.
Which one?
It was one I was missing, and I gave it to her because you weren't here, and she was like, "Yeah, I'll take it."
Ooh.
Rosa. She took it on.
Whatever. I haven't gotten it yet, but I'll take a look. She's not here today. So that's fine. All right. So, now there's a big difference between -2 squared and -2 squared. Right? We were talking about this the other day, right? If you see this, that equals -4. Okay? If you see this, that equals 4. See the difference? Okay? Because in math, I know you guys have been told this, but you've been lied to. So, welcome to life. Your parents lied to you all your life, and so do teachers. Okay? Because we care about you. And we don't want to fog up that head with the reality. And the reality is, there is no such thing as negative numbers. It's an illusion. Okay? Just like a lot of magic out there is an illusion. Not all magic. I believe in magic. But most magic. I believe in Santa Claus. But I'm just saying, when you don't get nothing. So I believe. Alright? But the point here is, there is no such thing as a negative number. What we do as mathematicians is we're lazy. Remember I said we're lazy? We don't want to write -1 times 2 all the time. So we write it as -2. Okay? We're lazy. And that's why this is really -1 times 2 squared. So you do the 2 first, and then you multiply it by the -1. Okay? And you guys see that a lot when we were doing the other problems where we had -x squared, right? You're plugging it in, and then this is making it negative, and it's very confusing, and right? Okay? So, just remember, this will be positive every time. This b squared will always be positive. So that's going to be 4. Okay? Here's the tricky point. So I'm going to change my color real quick. Okay? And this is what I focus on with my students. This is huge. And it can be kind of tricky. I'm not trying to make it tricky. I'm trying to make it easy. Think of it like this. What's a negative times a negative? Positive. That means this is changing to a plus. Okay? If you had just one of these were negative, right? Then it would stay negative. Does that make sense? If both of these were negative and this is negative, then it would stay negative, right? Because negative times a negative times a negative is a negative, right? So just keep that in mind. If you deal with your negatives first, then you'll know if you're adding or subtracting in here. Because that's where kids go wrong. Okay? Next, do the multiplying. What's 4 times 1? 4 times 9. 30 what? 6?
Oh, yeah.
Okay. I thought I heard 37. And I am wrong a lot on those things these days. I'm finding my age is catching up to me. And all that stuff I had memorized when I was a kid, it's harder to grasp. Okay? So, what now? Well, 2 times -1. What is 2 times -1? -2. Okay? And now it's just, okay, let's do what's in the, we'll do what's in that parentheses. Or, sorry, not the parentheses, but what's in the radical. So what is 4 plus 36? 4 plus 36? 40. Okay? Alright, people. This is where, excuse my French, the poop hits the fan. I would say the other word, but I'm on film. So, students have a hard time with this. Okay? With breaking down the radical. Okay? I've shown it. Hopefully you remember it. If you don't, I'm about to show it again. Okay? I teach breaking down the radical a little different than other schools and other people. Okay? I like using simple math. I like using the same thing over and over and over and over again. When I go bowling, I bowl straight. And I keep, if the pins move from the right side, I move left. And I just bowl straight. And I do pretty well. Do I get 300s? No. Can I get a 200? Yes. Just not very often. Because I don't have that hook shot. Okay? But I do the same thing every time. Okay? And what I want to do here is I want to take that 40 and I want to break it down using my primes. 2, 3, 5, 7, 11, 13. You guys are Algebra 2. These are your base primes. In pre-cal, we'll go up to 19. Okay? You're missing 17 and 19. Okay? But these are the ones you'll use the most. Okay? And you start off with the lowest prime. Is it even?
Yes.
Then it's divisible by 2, right?
Yes.
Alright, so we're going to divide by 2. How many times does 2 go into 40? Is it even?
Yes.
Then we're going to divide by 2. How many times does 2 go into 20? Is it even?
Yes.
Then we divide by 2.
5.
There we go. Is it even? No. Then we go to the next number. 3. Does 3 go into 5?
No.
No. Does 5 go into 5?
Yes.
Yes. 5 goes into 5 one time. When you get to 1, you're done. Okay? Every single time. Now the reason I do this is because it keeps it organized. It keeps it in a column. And I can take all those numbers in the column and I circle pairs. The reason I'm circled pairs is because this is a square root. Remember, a square root, if you remember, this was equal to this, right? You remember that? That was the beginning of the year. That square root one. 1/2 of an exponent is a square root. Okay, and we will get better into that later. What we're saying is, if you take 2, or let's use 3 squared, right? 3 squared. What is 3 squared? They just want me to take roll, and I haven't done it yet. All right. So then, what if I take half of 2? What's half of 2? 1. So this would be 3 to the 1, right? Which is 3. It's the same thing as if I took 3 squared and square rooted it. Because what's the square root of 9? 3. Okay? And that's what's happening. So I am pulling out a pair, and I trade the pair for one outside the box, or what I call the radical. Okay? Whatever's left not paired up goes in the radical. What is 2 times 5? 10. So this is 2 square roots of 10. So what we have here is 2 plus or minus 2 square roots of 10. Alright, before you guys freak out on me, hold on. One more thing. What goes into 2, 2, and 2? 2, right? But we want to get rid of this negative. So I'm going to divide by a -2. How many times does -2 go into 2? -1 time. How many times does -2 go into 2? -1 time. Okay? We don't touch inside. What's outside touches what's outside. What's inside touches what's inside. Okay? How many times does -2 go into -2? 1.